Hello guys, welcome into the final exam preparation sessions. Now in this three-part series, we'll be talking about functions, specifically talking about the questions that you'll be getting on the parabolas. Now, if you've been with me from the very beginning of this preparation session, I'd like to thank you for your loyalty and also thank you for your support. Now, if you're new to the channel, just be sure that you stick around a bit so that you can see that it is fun doing these typical questions on these final exam preparation sessions. And please don't forget to subscribe so that you won't miss when another video gets uploaded. So without further ado, we're going to start with the first video of the three-part series of the functions in parabolas. Now, starting off with our first video, we'll be looking into question 6 of September 2019. Now, the question goes as follows. In the diagram, the graphs of f of x, which is equals to minus x squared plus 5x plus 6, and g of x, which is equals to x plus 1, are drawn below. The graph of f intersects the x-axis at b and c and the y-axis at a. The graph of g intersects the graph of f at b and s. PQR is perpendicular to the x-axis with points P and Q on F and G respectively. M is the turning point of F. Now, before we go to the question, what we're going to do first is to analyze what we are given here on this statement here. So here we are told on this side, I want to start with f of x. So f of x here, we are told that it is minus x squared plus 5x plus 6, right? Now here I can say that with this, I know that the value for A is minus 1, the value for B is equals to 5, and the value for C is equals to 6. All right, now what else do we have here? Now, another thing that we have about F here, we are told that the graph of F intersects the x-axis at B and C. Right, so if it intersects the x-axis, we know here we are being told about what? About the x-intercepts. Now, our x-intercepts are B and C. What about the third thing here? The third thing here, we're told that the graph intersects the y-axis where at A. So if it's the y-axis, then it means that is the y-intercept. Now, the y-intercept is going to be point A. All right. Now here, another thing that we're told here is that the graph of G intersects the graph of F at B and S. Okay, so this one, we can just take it over to G of X. Now let's go ahead and write about G of X. Now G of X, we're told that it is X plus 1. All right. Now X plus 1, what can I take there? I can see that my gradient here, my gradient is 1, right? And also I can see that my C or my y-intercept, it is also 1. Okay, now how do I know that my y-intercept is 1? Or my y-intercept point, actually, point, it needs to be a point. Your y-intercept is 0 is to 1. So how do I know that? So I know this because of this constant here, right? Second thing that we told about G is that the graph of G intersects the graph of F at B and S. So what does this mean? So this means that the graph of G of X is equals to the graph of F of X. So this means they intersect, right? So whenever graphs intersect, it means they are equal. So where do they intersect? So they intersect at B and S. All right. Now the next thing here that we're told here is that PQR is perpendicular to the x-axis, right? Now let's add this one as a new one. So PQR is perpendicular to the x-axis. Now looking into the diagram, what does that mean if PQR is perpendicular to the x-axis? So it means if this is the line here, PQR perpendicular to the x-axis, then this means PQR is going to be parallel to what? to the y-axis, right? So let me just write that. So this means now PQR is going to be parallel to y-axis. So how is this going to help me? So this thing is going to help you to calculate the length of PQ or of QR or of PR, given that you don't know the coordinates of P and Q. So in most cases, it can be PQ, since P is on F and Q is on G, right? Okay. Now what else here? We told that, okay, there we go. Here we can see here we're told that P is on F and Q is on G. So which means here on my F, I can say P is on F of X. Then over here, let me edit here. I can say Q is on G of X. All right. Now the last point, it says M is the turning point of F. Now here M is turning point. So TP of F of X. All right. So if M is the turning point of F, then this means that the x coordinate of that turning point, since we have a quadratic formula there, is going to be minus b over 2a. And then to get the y coordinate, we're going to simplify the x coordinate, then take that x coordinate or that x value and substitute it there on the equation to generate us the y value. All right, so now that we have broken down everything on the question, let's go ahead and look into the first question. Now the first question says, write down the coordinates of A. Now if you remember the coordinates of A, we said here that the coordinates of A were what? A y-intercept, right? All right, so now it's the y-intercept of F. So this then means now here to calculate 6.1, we're going to say in y-intercept, we let x to be 0, right? Now on our equation of F, it's going to be y equals to minus 0 squared plus 5 into 0 plus 6. Then when you press this in your calculator, this gives you 6. Then this means the coordinate of A is going to be 0 to 6, right? Now 6.2 says S is the reflection of A about the axis of symmetry of F. Calculate the coordinates of S. All right. Now here we're told that S is a reflection of A about the axis of symmetry. So what are axes of symmetry? So axis of symmetry, it is a line that divides the graph of F into two equal halves. So what do I mean by that? So do you see this sketch of F here? So we need to cut this sketch into two equal halves. So to do that, it means you're gonna cut it on the x coordinate of the turning point, right? All right, so now this then means now what we need to do is I need to understand what is that x coordinate. So to do that, what I'm going to do is I'm going to say the axis of symmetry, the equation for the axis of symmetry is going to be x equals to minus b over 2a. Now remember, that's the x coordinate, right, of the turning point. Now here I see that my b is 5 over 2, then my a is minus 1, and then press this on your calculator, you get 5 over 2. Now what does this 5 over 2 mean? So this 5 over 2 means that from this point to the left, it's going to be 5 over 2, and also from this point to the right, it's also going to be 5 over 2. Now if now S is the reflection of A, right, about this line, it then means now from here we know that the x coordinate for A, it was 0. Then now here to get to this point, we're going to add by 5 over 2 twice, right? So this then means now here we know that the x coordinate, therefore x coordinate of S is going to be 0, which is where we started from A, plus 5 over 2. So it means here this 5 over 2 we're getting into this axis of symmetry plus another 5 over 2, which lends us to the x coordinate of S, right? Then now when you press this on your calculator, it should give you 5. Now, what about the y value? Now, the y value, since it's a reflection, right, is going to be the same as the y value of what? Of A. So this means now the y value of S is going to be 6. Now, this means that the coordinate of S is going to be 5 is to 6. Now, 6.3. Now, 6.3 says calculate the coordinates of B and C. Now, if you remember, in the instruction, we're told that the graph of F intersects the x-axis at B and C. Earlier on, we said that whenever the graph intersects the x-axis, it means there we want to find what? The x-intercept. So here what we're going to do then, we're going to say in x-intercept, we're going to let y to be equals to 0. So in F, what we're going to do now, we're going to substitute 0 equals to minus x squared plus 5x plus 6, right? So I want to take this over this side, so it's going to be x squared minus 5x minus 6 equals to 0. And then when I factorize here, I'm going to get x and x 1 6 minus and a plus, right? So this gives me x as minus 1 or x as 6. Now, as you can see in the diagram, here B is in the negative, right? And then C here is in the positive x-axis. So that means now the coordinate of B is minus 1 is to 0. And the coordinate of C is 6 is to 0. Now let's go ahead and look into 6.4. Now 6.4 says, if PQ is 5 units, calculate the length of OR. Now PQ, what is PQ? PQ is the length from here to here, right? So we're told here, if this is 5 units, now we need to find what this length is going to be. Now earlier on I said, now if PQR is perpendicular to the x-axis, it means now that PQR is also parallel to the y-axis. Now if that's the case, then it means now to calculate in general the length of PQ, right? We'll need to take the y value at the top, which is the y value of P, and then subtract the y value at the bottom, which is the y value of Q. But now here, as you can see here, we're not told what were the points of what of P and Q, but we're told that P is on F and Q is on G. So this then means now, in general, PQ is going to be the equation of F, right? Which is going to be F of X minus the equation of G, which is G of X. Now let's go ahead and put this here. So we're saying now F of X minus G of X, which is PQ, is equals to what? Is equals to 5 units. 5 units. Now what is the equation of F of X? F of X is minus x squared plus 5x plus 6 minus, now G of X is x plus 1 equals to 5. So let's see what you get when you simplify here. So we're going to get minus x minus 1, take the 5 over, it's going to be minus 5 equals to 0. Let's see if you can go to the next slide here. So here I have minus x squared, so let me put minus x squared, and then here 5x minus 1x gives me 4x, so plus 4x. And then here 6 minus 1 gives me 5. Now 5 minus 5 is going to give me 0. So I'll just have this equals to 0. Now here let me divide by negative 1. And then I'm going to get x squared minus 4x equals to 0. And then x into x minus 4 equals to 0. X is 0 or x is 4, right? Now since here we can see what is happening here, we can see that PQ, right, PQ is not on the y-axis, right, is on the right of the y-axis, which means the value here for P and Q, the x values here needs to be positive. Hence now here we're going to say that the x value of P is going to be the same as the x value of Q, and also be the same as the x value of R, which are all equals to 4. Now to calculate now the length of OR, the length of OR, since the OR is on the x-axis, I'm going to take the x coordinate on the right, and then we're going to subtract the x coordinate on the left, right? Now what is the x coordinate on the right? It's going to be xr, right? The one on the left is going to be xo. Now what is the value for xr? It's 4 minus the value for xo, 0. Now this gives me 4 units. So I hope that makes sense. Now we're down in 6.4. Let's go ahead and look into 6.5, which is the last question. Now here they're saying calculate the coordinates of M. Now M, we're told that it is the turning point of what? Of F. Okay. So 6.5, we're going to say 6.5.1. Now here, the x coordinate of M already, we had it as our axis of symmetry, right? So this means now xm is going to be 5/2. Now to get the y coordinate, we're going to say y equals to, we're going to take the value and substitute it there. So it's going to be 5/2 squared plus 5 into 5/2 plus 6. Now if you press that on your calculator, you're going to get the y coordinate of m as 49/4. So this then means now m is going to be 5/2 is to 49/4. And let's look at the last question. The last question says now we need to calculate the maximum length, right, of PQ between B and S. So here the first thing that we need to do is we need to calculate the length of PQ, right, using the formulas for F and for Q, right? All right. Now, what we're going to do here is in 6.5.2, we're going to say PQ, like we said earlier, is equals to f of x minus g of x. Now this means it's going to be minus x squared plus 5x plus 6 minus x plus 1. Now let's simplify this. When I get x squared plus 5x plus 6 minus x minus 1. Now this gives us minus x squared plus 4x plus 5. All right. Now, the equation for PQ, the length for PQ is found by having minus x squared plus 4x plus 5. Now, this is a quadratic expression, right? Now, whenever you have a quadratic expression, we know that to have a maximum, right, or a minimum, we can do two things. First thing that we can do is we can find the x coordinate of this, right? Which means by saying x is equals to minus b over 2a, right? Then after we got the x coordinate, we can take the x coordinate and substitute it here to get the y coordinate. So the y coordinate is going to be the actual length here. Or the much more quicker way, what we can do is we can find the derivative of this, right? So we can make the derivative of this to be equals to 0, right? So we can say d pq over dx equals to 0. Now I want to use this one because this one is going to be much more quicker. So let's go ahead and do that one. So the derivative of PQ with respect to x is going to be minus 2x, right? Plus 4. Then you're going to equate that with 0. So as you can see here, this gives me the x coordinate that I'm looking for quicker, right? But now this is not the value that I want here, right? But I know this is the value that's going to give me what? A maximum. Now to get the maximum length of PQ, when I say PQ, it's going to be minus 2 squared plus 4 into 2 plus 5, right? Now when you press that on your calculator, you're going to get 9 units. Now 9 units is the maximum length that you're going to get between what? Between B and S for PQ. And that is final answer for this part series. Now that is all I got for you today. If you like the video, please please be sure that you subscribe so that you won't miss when I do the second one, where I explain again the another type of the parabola questions that will be working on for your final exam preparation sessions. And I'm gonna see you on today next video. Cheers.